Okay, 8.1, similar polygons. Setting up your ratios. We did this earlier, and then now we're going to talk about perimeters and areas of polygons. So let's first go through the scale factor problems. Okay, so find the scale factor, and then list all the pairs of congruent angles and write the ratios of the corresponding side length in a statement of proportionality. Okay, scale factor first. Scale factor, we're going to use these two. So that's 8 over 6 because we're getting bigger. So the bigger number goes on top. And so that's 4/3 for the scale factor, which we'll call K. Then list all pairs of congruent angles. All right, so we use this to list them. So angle A is equal to angle L, and angle B is equal to angle M. Angle C is equal to angle N. And then write the ratios of the corresponding side lengths. Okay, so 8 is to 6, as 6 is to 4.5, as 9 is to 6.75. Okay, number 2, same type of thing. So I'm going to use QR and EF. So these two right here, we're getting bigger, so we put the bigger number on top. So the scale factor is 3 over 1. And listing the angles, so we'll have, again, we'll use this order. So angle D is equal to angle P, angle E is equal to angle Q, angle F is equal to angle R, and angle G is equal to angle S. And then the numbers, this is a little more difficult. Again, we'll say DE is 9. Well, let's start with the bigger side first. So PQ and DE. PQ is 3, and DE is 9. And then we do QR and EF. QR is 1, EF is 3. And then we have RS and FG. RS is 4, FG is 12. And the last one, the beginning to the end, DG, SP and GD, which is SP is 2 and GD is 6. So all those reduce to 1/3. Next one, which are the polygons are similar, so find the value of X. All right, so they're in the correct order and the way it's shaped. So I'll just do this. X is to 20 and you pick either of the other two sides. All right, 21 is to 14. So 14x equals 420, divide off the 14. So x is 30. Number 4, these are flipped around. So x is going to be to 18 as 20 is to 15. So 15x equals 20 times 18 is 360. Divide by the 15, and you get 24. Number 5. These are in the correct order, the way they're shaped. So x is to 22, and then just pick anything else. So 6 is to 12. So they're going by 1/2, so x is going to be 11, so that's 12x. 6 times 22 is 132. We divide by 12. X is 11. Same thing, these are arranged properly. So again, x is to 8, as just pick anything else. 9 is to 6. So what do we get? 6x equals 72. Divide off the 6. X is 12. Identify the type of segment shown. So the type of segment here is an altitude. And so now we set everything up. X is to 16, as 27 is to 18. So 18x equals 16 times 27, which is 432. And then we divide off the 18, and x is 24. Number 8, again, let's see, the dotted line is a median. And so that's y is to 16, y minus 1 is to 16 as y is to 18. And then we have to distribute there. That's 18y minus 18 equals 16y. So I'll subtract 16y and add 18 to the right. So I get 2y equals 18, y equals 9. Find the ratio of their perimeters. So the ratio of the perimeters is the same as the ratio of the legs. So the ratio of the legs, the only leg we have is ST. ST is the same as BC. So the ratio there is 12 to 8. Reduce that by 4, we get 3 halves. So the ratio should be 3 halves. Okay, same thing. The perimeter ratio, if we had all the values, we could add them all up, it'd be the exact same thing as if you chose those two ratios. So again, 18 to 24 or 24 to 18, it doesn't really matter. They're not asking for scale factor, they just want the ratio. So 24 to 18 divide by 6, we get 4/3. Two polygons are similar. The perimeter of one polygon and the ratio of the corresponding side lengths are given. So here's the ratio. Find the perimeter of the other polygon. So the smaller polygon is 48. Okay, so let's just say it's a quadrilateral. We don't know. And the bigger one is here. The smaller one, the perimeter is 48. We don't know this one. So we're going to do small to large. Oh, let's do it this way. Large to small. So x is to 48. Let's change that to the other one since we have the small number on top. That means we're getting smaller. Okay, so we'll put the small number on top over the larger number, so it matches the correct ratio that we have here. So we multiply here. That's 120, and 24 is 144. 3 times 48, and that's 2x. Divide off the 2, and you get 72. Should be the perimeter of the larger polygon. Okay, so let's take a look at number 12 here. Get rid of all this stuff and do it again. So number 12, perimeter of smaller polygon. Again, the same as number 11. So if we just have two polygons, we don't know if it's 4-sided, 5-sided, 20-sided, we don't care. Okay, the point is just visually, the perimeter of the smaller one is 66. The ratio from small to big is 3/4. So you don't know the big perimeter, but 66, the smallest to the largest, would be the same as the smallest to the largest here. Okay, the ratio of the sides is 3/4, so the ratio of the perimeters is the same, 66 to x. Cross multiply, so 3x is equal to 4 times 64. 4 times 60 is 240, and 4 times 6 is 24. So 240 and 24 is 264. Divide by 3. 3 goes into 26 8 times with a remainder of 2. 3 goes into 24 8 times. So 264 divided by 3 is 88. So that would be the perimeter of the larger polygon. Okay? Let's erase that and do number 13. All right, and now we want the perimeter of the smaller polygon. We have the larger polygon, that's 120 yards. Okay, we don't know the smaller one. And again, the ratio is 1 to 6. So since the smaller numbers are on top, we'll put x on top because it represents the smaller perimeter. And the ratio is 1 to 6 on the sides. So they're supposed to be the same, small to large and small to large. So cross multiply, and we divide, and x equals 20. So the perimeter of the smaller polygon is 20. Let's erase that and do the next one, which will be the same type of problem. So number 14, the perimeter of the larger polygon is 85 meters. We haven't been putting the units on, so we should probably do that. And the ratio is 2 to 5. So again, since the smaller number's on top here, we'll put the smaller perimeter on top. So x is to 85 as the ratio of the lengths of the sides is 2 to 5. Cross multiply, so 5x is equal to 170. Divide by 5. Again, you should be able to do this. 5 goes into 17 3 times with a remainder of 2. 5 then goes into 20 4 times. So 170 divided by 5 is 34. Learn how to do that. Okay, those are the answers for that. Now let's get the next set of problems. And these are the answers to all of those problems. Notice the last problem was 34 meters, and that's what we had. All right, next slide. Scientists rope off 2 excavation sites. Site A is rectangular with a length of 60 meters, okay, 60 meters, and a width of 40. So this is length, width is 40. Site B, this is site A, site B is similar in shape to site A, but has a length of 45 meters. So it's a little bit smaller. The length is 45 meters, and it wants to know what the width is. How much rope is needed for both sites? Okay, so we don't know what the width is. We could figure it out by saying this is x. And again, doing 40 is to x is 60 is to 45 and figure that out and do all of what it is we're trying to do. Okay, so let's set that up. 40 is to x as 60 is to 45. And now we can figure out what x is, or the width of the smaller lot. So cross multiply, that's 60x, equals 40 times 45. So take your calculator. And you could do it without it, but we'll go ahead and use our calculators here. 40, let me get the calculator up here. 40 times 45, and that gives me 1800. Okay, and now we divide by 60. And I want to show you a little trick here. If you have zeros at the end, you can just cross those out. And now you have 180 divided by 6. Well, that should be 30. 18 divided by 6 is 3, so 180 divided by 6 is 30. So if x is 30, and these are rectangles, so that's 30, that's 45, this is 40 over here, and this is 60 up here. So what's the perimeter? So add all those together. 60 and 40 is 100, that's 100, so that's 200, that's the perimeter of the big one. The small one is 75, and 75 is 150. So that's the perimeter of the small one. So it says how much rope is needed for both sites. Now these are meters here. So you add those two perimeters together. So 200 and 150 makes 350 meters of rope to go around all the sites. Your family decides to put a rectangular patio in your backyard, similar to the shape of your backyard. Your backyard has a length of 45 feet and a width of 20 feet. The length of your new patio is 18 feet. Find the perimeter of your backyard find the perimeter of your backyard and the perimeter of the patio. Okay, so the perimeters are proportional. So this is 45, this is 20. So you have 65 and 65, that makes 130. So the perimeter is 130. The perimeter of your patio, we don't know. Okay, but we do know the lengths of the legs. Oops, not the 20. Length to length here. All right, so 18 is to 45 as the perimeter of our patio is 230. How do I know which one goes on top? Well, I started with the patio on top and I got the backyard on the bottom. So the perimeter of the patio goes on top and the perimeter of the backyard goes on the bottom. So they match. Now you just cross multiply. So you're going to need your calculator again. So we take that and do, 45x, and then 18 times 130. So that's 2,340. We're going to divide off the 45, and we get 52. Now that's not the answer. That's the width. Okay? I'm sorry, that's the perimeter of the patio is 52. That's what we wanted, which actually is x. Okay, so 52 is the perimeter of the patio. So patio is 52, and the backyard, we already calculated, that's 130. Those are the two answers you needed. Okay, now 17 through 20. The polygons are similar. The area of one polygon is given. Find the area of the other polygon. Okay, so areas are already squared. So the area of the smaller one is to the area of the bigger one as the length of the sides are to each other, of the small one to the large one. But you have to square these values, okay? So the area of the small one is 27. We don't know the area of the big one, okay? The length of the sides, okay, would be 3 of the small to 6 of the large, but we need to square those values. So 27 is to x as 9 is to 36. 9x equals 27 times 36, 972, divided by 9, and x is 108. The area of the other polygon is 108 square feet. Okay, the area of the small one again is 10. We don't know the area of the large one, call it x. And the lengths of their sides is 4 to 12. But again, square each of those. So 10 is to x as 16 is to 144. 16x equals 1,440. So we divide by 16. 1440 divided by 16 is 90. So the area of the larger triangle is 90 square centimeters. Number 19, we have the area of the large one. We don't know the area of the smaller one here, so x is to 100 as 4 is to 20, but we need to square those again. So x is to 100 as 16 is to 400. So 400x equals 1600. So divide by 400. Again, a little trick here. If you have zeros at the end, you can reduce them out. And x equals 4. So the area of the small rectangle there is 4 square inches. So if the length is 4, just something to observe, the area of a rectangle is base times height. The height must be 1 inch. Okay, moving on to number 20. Area of the large one is there. We do not know the area of the small triangle. So x is to 96 as 3 is to 12. And again, square each of those. So x is to 96 as 9 is to 144. So 144x is to 9 times 96, 864. So we're dividing by 144, and that gives us 6. And its area, so this is square centimeters. Okay, so describe and correct the error here. What they did is they said 5 is to 10. Well, we should solve it first. Let's find the area, or the perimeter of triangle B. So, again, if we're going to follow my arrows here, the length of the sides, the ratio of that is 5 to 10. We don't know the area of, or the perimeter of B, but we do know the perimeter of A. We can add these together. So 10 plus 6 is 16 plus 12 is 28. And now we cross multiply. So we'll say 10x equals 140. Divide by 10, and x is 14. Now, here's our ratio. There's theirs. What did they do? They flip-flop their ratios. This right here should be x over 28. Or they should have flipped this one. One or the other. One of them needs to change. That's what they did wrong. So the perimeter of the small one is 14. Okay, so what they do wrong here, instead of looking, let's go ahead and solve. We want the area of rectangle B, the bigger area. So again, the areas together, 24 is to x, as the side lengths are squared to each other. Remember, area is already squared. You got to square the legs. So we get 24 over x equals 36, and 18 squared is 324. Got to multiply, cross multiply, 36x. Multiply that by 24 and you get 7,776. We divide off the 36 and you get 216. So the area of the bigger rectangle is 216 square units. Okay, let me write that a little bit nicer. Okay, so what did they do wrong? Here is their proportion. Does it match ours? Sure does, except for they did not square their legs. 23, decide whether the red and blue polygons are similar. Okay, so we just have to match up their pieces, okay? So the long side here is 40, the long side is 30. All right, and so we could say 40 is to 30 as the sides are to each other. 30 is to 22.5. Well, they're supposed to match. You could go ahead and use your calculator and figure out what that is, or you can cross multiply. 30 times 30 is 900, and if they're similar, then the right side should be 900. So 40 times 22.5 gives me 900. So yes, they are similar. But they aren't really similar. We found that the legs are proportional, but these angles are supposed to be the same from the red to the blue. And there's no way, let me erase a lot of these marks here so we can kind of look at these. Let me blow this up so we can see it a little bit better. Okay, so are you really telling me that this angle right here is the same as that angle? And it caught you off guard because all we've really been doing is catching the legs. We haven't been noticing the angles. So one thing to remember, you do have to have exactly the same angles in all the corresponding positions. So this is kind of a trick question. So proportionally, yes, it is as far as legs are concerned, but the angles are not. So the correct answer is no. All right, so now we have the two figures where none of the positions, nothing's in the same position here. Okay, this 3 is the side, and we have no sides on the big one. This 3 is the side, and there's no sides there. All these 3s are on the insides, and we don't have any of that information in the other one. So we need to figure a few things out. So what is, we could do perimeters, we could do areas. Probably best if we just figured out a few things here. So I have a right triangle in the red one here where, let me see if I draw it just like what they have there. So this is 3, that's 3. Well, what is the hypotenuse? You can use the Pythagorean theorem to get the hypotenuse. So we're looking at this triangle right here. All right? And all 3 triangles, 1, 2, 3, are the same. So let's get what h is here. So you use the Pythagorean theorem, 3 squared plus 3 squared is equal to the hypotenuse squared. So 9 plus 9 is equal to h squared. 18 equals h squared. Take the square root, and that's 9 and 2, or 3 square root of 2. That's h. And that's going to be h all the way around. All those legs are the same. Well, now we have different pieces here. We have the sides. This is to that side as this h is to that side. That makes sense because you have 3 square root of 2 for your hypotenuse is to the same corresponding position, and that's the same as 3 square root of 2. The base up here is to the base of the blue one. So those are equal. All right, when you reduce those are the same. Well, they look the same here anyway. So we are saying that these are similar. What about their angles? Well, notice we have these two sides are the same, which makes this, and this is 90, which makes these 45 degrees. Well, this is 90 degrees. These two sides are the same, which makes these two 45 degrees. So all the angles do match. So yes, we do have proportional and similar polygons. So exercises 25 through 32. Find the scale factor of JKLM, so the big one to the small one, EFGH. So the scale factor, let's just pick the two same sides. Let's pick, JK, we'll go with EF. So make sure you're paying attention to what those really are. 20 is to 8. If you said 20 is to 11, you're setting it up wrong. All right, so it says they are similar, so I only need to find 2 of the correct legs to use. So 20 over 8, so our scale factor reduces by 4 to give me 5 halves. 5 halves is your scale factor, but we're getting smaller, so we need to put the smaller number on top. 2/5 is the correct scale factor. Now list all pairs of congruent angles. All right, so we just use this to help us. Angle J is equal to, or congruent, it says congruent to angle E. We'd use the equal sign if we knew the degrees. And so angle K is congruent to angle F. And angle L is congruent to angle G. And angle M is congruent to angle H. All right, next one, 27. Write the ratios of the corresponding side lengths in a statement of proportionality. Again, we'll use these two things. So let's say JK is to EF as the next set, KL is to FG, and the next set, LM is to GH, and then the first and the last, MJ is to HE. And finally, number 28, find the values of X, Y, and Z. All right, so we have our scale factor. We could use that, but we'll set up the proportions because that's probably what you're going to do. So we need to make sure we set these up right. So I'm going to move this up just a little bit. And again, I'm going to focus on the order here and the order that we have here. Okay, so if I just use number 27, I can set these up and figure out X, Y, and Z. So let's just do all of these 4 fractions here. JK is 20, EF is 8, KL is X, FG is 11, LM is nothing, we don't know that, and GH goes with it just for fun. Okay, and MJ is 30, and HE is Y. So where is Z? Z happens to be an angle. Okay, so what does angle E go with? So we look at our letters here. Angle E is the first letter in this polygon, so we need to use angle J, and angle J is 65. So right off the bat, we know Z is 65 degrees. Okay, so how do we get the rest? Let's use this proportion to get X, and we get 20 times 11 is 220, and that's 8x, so we divide by 8. 8 goes into 22, 2 times, that's 16 with a remainder of 6, and it goes into 67 times with a remainder of 4, so this is 0.0, put the 4 in front of that. 8 goes into 40 5 times, so 27.5. You could use your calculator, it's okay. Okay, that's X. So we have Z, we have X. Now how do we get Y? Well, let's use this ratio with the 20 over 8. So 20 over 8 is to 20 is to 8 as 30, sorry, is to Y. Forgot what we're doing. 20 times Y, and 8 times 30 is, 8 times 3 is 24, add 0. So 8 times 30 is 240. Divide by 20. So if we divide by 20, cross out those last zeros, 24 divided by 2 is 12. So that is your Y value. Okay, let's move on to the next one. So we're at 29 here. It's the same setup, but we have different things we want to do. So let me put these other values in here. What was X? Let me pause it and write these numbers in. Okay, so there's what X and Y are. Find the perimeter of each polygon. So we don't know ML. We can figure it out now if we wanted to. Let me put that other value on there. We could do it with using scale factors. But let's see, what was that scale factor? Hold on. That scale factor was 2/5. I'm going to actually do the scale factor to show you how to get ML. Okay, so ML goes with GH, okay? So since I'm getting the bigger value here, ML's bigger, I'm going to turn this into 5 halves, and I'm going to multiply GH by 5 halves to get me what ML is. So GH is 3, so 5 halves times 3 gives me 15 over 2, or 7.5. So now I can just add all those together, and that gives me the perimeter of each of the polygons. You could set up a proportion if you wanted and find ML. So 3, 12 is 15, plus 8 is 23, plus 11 is 34. So that's 34 for the small one. And 20 plus 30 is 50, plus 7.5 is 57.5. And then we do the 57.5 plus the 27.5, and we get 85. So the perimeter of both of those is 34 and 85. Find the ratio of the perimeters. Well, it'll be the same as the ratio of your legs. So you could do, let's use the 20 over 8 again, or whatever, 20 over 8, which reduced, remember, to 5 halves. It's the exact same thing as what we have. So just to show you that these are the same, this reduces to 5 halves. So 85 over 34 ought to reduce to 2.5. So take 85 divided by 34, and you get 2.5. So both of these are 2.5. They are the same. The ratio of the perimeters is the same as the ratio of the side lengths. Find the area of each polygon. Oh, now we got to get the area. So let me erase a bunch of these draw markings. Oops, I erased what we needed for some of it. Alright, so that was 27.5. I forget what y was. Y was 12. Okay, the area of a trapezoid is 1/2 base 1 plus base 2 times the height. So the area of the smaller trapezoid is 1/2. The two bases, okay, are your parallel sides. So 3 and 8 are your parallel sides. So 3 plus 8. And your height is an altitude. It can't be 12, it has to be 11. This is an altitude over here, GF is an altitude. So times 11. So this is all tricky how they have it set up. So you have 11 here. 11 times 11 is 121. So 121 over 2. So divide that by 2, and you get 60.5 square units for the smaller trapezoid. Now, the bigger trapezoid is 1/2 the parallel sides, so 20 plus 7.5, times the height. Again, it has to be an altitude, so 27.5. Now, there's other ways of doing this. They want you to use the formula that the areas squared, they're already squared, is equal to the side length squared. So I'm going to do that in a minute just to show you. But you can just use your normal math to figure it out. But if you don't remember the formulas, then it doesn't help. So 27.5 times 27.5, and then you got to divide that by 2. And you get 378.125 square units. All right. So let me erase some of this other stuff and show you how to use the formula to find the areas. So let's say we found the area of the one, we'll use the smaller one, 60.5, and we don't know the area of the bigger one, but we know the side lengths. All right. So the side lengths, since we're using calculator, we'll just do that. HG is the same as LM. So 3, the small one, is to 7.5. So 3x is equal to 60.5 times 7.5. That's 453.75. And we divide by 3. Oh, wait, we forgot. We're supposed to square each of those. So that's going to be 9x. 7.5 times 7.5. 7.5 times 7.5. It's 56.25. And so you take 56.25 times 60.5. And that gives you 3,403.125, and we divide by 9 on your calculator, and you get that number. So you could use your proportional setup, your formulas, or try to remember your trapezoid formulas. Either way, you have to know a formula. All right, next one. We need to write the ratio of the areas. So 60.5 over 378.125. Remember, that's the same as your side length squared, 9 over 56.25, or 56.25 over 9, depending on which way you're going to write it. Okay, so that's the ratio from small to large. I mean, if you did large to small, 56.25 over 9, which is going to be 6.25. If we turned everything over and just did long division, okay? And of course, they're not going to write it like that. They're going to leave everything in fraction form. The 60.5 is 60 and 1/2. The 378 is 378 and 1/8. I mean, it's crazy how they have these set up. But you just got to be able to go back and forth between fractions and decimals. You have to. You're in high school. This is what you need to be doing. You have to learn this process. So let's go on. And of course, here are your answers. Just to look at that last one we talked about. There's 31, which is what we said. And then 25/4 is 6 and 1/4, or 6.25, like I said. All right, let's go on to the couple here. In table tennis, the table is a rectangle 9 feet long, okay, and 5 feet wide. A tennis court, 9 and 5. So let me erase the junk I just wrote. And a tennis court is a rectangle 78 feet long and 36 feet wide. Are the two surfaces similar? Well, first of all, everything is at 90 degrees, so these are rectangles for sure, so their angles are the same. So now, let's see if they're similar. We'll set everything up. So width is to width, 5 is to 36, as length is to length, 9 is to 78. So cross multiply. 5 times 78 is 390. We already know the angles are correct, and 9 times 36 is 324. So the answer is no. They're not similar. Okay, so right, no, they're not similar. Okay, now, it says the figures are similar. So find the missing corresponding side length. So figure A has perimeter 72. So we don't know the perimeter of B. One of the side lengths of A is 18. Okay. Oh, and it does tell you the perimeter of figure B is 120. So what we don't know is the length of figure B. Okay. The side length of figure A is 18. The side length we don't know of figure B. Okay, so now we set the perimeters to each other and the side lengths to each other and figure it out. So that's 72x and 120 times 18. And that gives us 2160. So divide that by 72, and the side length should be 30. All right, 38. Figure A has a perimeter of 24. Figure B has a perimeter of 36. And one of the sides of figure B is 12. So since 36 is on the bottom, we'll put 12 on the bottom. That's figure B. So A is up here, B is down there. So we don't know the side length of one of the lengths of figure A. So again, cross multiply, 36x equals 24 times 12 is 288. Divide by 36, and we get the side length to be 8. Now, area. Figure A has an area, so A is on top, we'll do that, and B on the bottom. Figure A has an area of 48 square feet, and one of the side lengths is 6. Figure B has an area of 75, and we don't know the side length of figure B. But remember, you're supposed to square each of the side lengths. And of course, that gives us 48x squared equal to 6 squared is 36 times 75 is going to be 2,700. So divide that by 48, and you get x squared equals 56.25. And now we take the square root of 56.25, and that gives us 7.5. And then 40, figure A has an area of 18, and figure B has an area of 98. Now, one of the side lengths of figure B is 14, so we don't know the side length of figure A. So again, it's area, so we have to square the side lengths. So here we have 98 x squared equals, take 14 squared first. So 14 squared is 196, and then times it by 18, and you get 3,528. Divide that by 98, and we get x squared equals 36. So x is 6 feet. And we won't do number 41. So good job. You got all those done.